Okay, for your mixed practice, this is page 9 in your spiral notebook. You're going to need your orange center of triangles. You can use this side or this side, the table side, but we're going to have to focus on making sure you can identify the special segment. So there's 4 of them, including mid-segment, which was on the purple paper, sheet. Know the definition, be able to apply it, recognize it by the markings. The markings are very important, and I had wrote some hints on the table to help you identify that. So just to recap, we looked at, or some of us got to look at, the different special segments in this animation we have here. And so if it lets go, this first one I have up here, the dotted lines are perpendicular bisectors. In a triangle, the 3 perpendicular bisectors, well, to be perpendicular, has to go through the midpoint, has to make a 90-degree angle, so tick marks in a box. When they intersect, this blue dot here is the circumcenter. It's the intersection of the 3 perpendicular bisectors. When you have 3 or more points, 3 or more lines that intersect, that point of intersection is the point of concurrency. And so whenever the perpendicular bisectors intersect, that point is called the circumcenter, and it is the center of the circle. The triangle becomes circumscribed, and there's a property that you don't need on this first test, but we're going to apply it for the second test, and we'll do this after Tuesday, and that is that the blue lines are showing equal distance to the vertices. So the circumcenter is always equal distance to the vertices. Another special segment is dealing with angle bisectors. And so here, we're showing you that the angles are bisected. And when the angle bisectors intersect, the point of concurrency is called the end center. If you look, it's the center of the circle inside the triangle. And I can change the type of triangle I have here. And it's not going to affect the distance, the radius of the circle, okay? The distance from the end center, the point of intersection, to the side of the triangles are all the same. So that's the property for that one. And then the next special property, because altitude does not have a special property that we're going to apply, is dealing with median. So right here, I'm showing a midpoint, another midpoint, another midpoint. When I connect the midpoint to the opposite vertex, that's a median. So the dotted line is the median. Oops, sorry. And then here's the other median. And there's the third median. When they all intersect, they intersect at one point. That point of concurrency is called the centroid. And now, also, there's a relationship. The point of the centroid, that point of intersection, is 2/3 the length of the median. So if you look at my green median, I have 2 segments, 2 tick marks to 1. Same thing with the purple, 2 to 1, 2 to 1. So if I had this part to be 4, okay, then hopefully we know this would be 8, and so the whole thing would be 12. And so that's just another property we're going to get into afterwards. But like I said, use this table on your mixed practice. The first thing and what you're going to be asked to do on the test is just identify the special segment by its markings. Okay, we can have them all in one triangle or separated. So hopefully, if it's just a box, we're just showing perpendicular from a side to a vertex, that is an altitude. So A is an altitude. Here we have a box and tick mark, so it's perpendicular and it's going through the midpoint. We have a bisector. C, this is what we did on the purple paper. Hopefully we know that's a mid-segment. D, we're just showing the arcs. So that is an angle bisector. That's 3. E is just going through the tick marks are showing we have a midpoint. So this is a median. If I just have tick marks, we have a median. So that's 5. 4, now we're showing all 3 medians. 4, sorry. G is your angle bisector. H, just box. So we have nothing but altitudes. Another mid-segment. And the last one is a perpendicular bisector, because you have tick marks and the box. So we want to be able to identify the segment based on the marking. Now here, I'm telling you it's a perpendicular bisector. So you have the box, you add the tick marks. And whenever that happens, this also happens. You have equal distance on that bisector. You create some isosceles, possibly equilateral, depending on the angle measurement triangle. So it basically says if FH, if this whole segment is 100, and EH, this is 100, so what is EF? Well, I know EH and EF are congruent to equal distance, so this would also have to be 100. So this would be an example of it's an isosceles triangle. Now the problem for the next one's going to change. If I can get it, let's see. Yep. So now it's saying, let me just erase this, but our markings and our relationship still is true. Given if EF is 13 and FH, this whole thing, is 10, and EH, I already did that one, is 13. Oh, EF, excuse me. EF and EH is 13. So now we have an isosceles. Find GH. Well, GH, did I do that right? Sorry, FH. GH, half the segment. So it's 5. Sorry, I'm looking at it wrong. So yeah, you're going to have to find the missing parts using your special segments and the properties on the 5 notes. Now we're just going to apply that you can do the perpendicular bisector. This is what we did on the worksheet on page 9, our spiral. So the first thing, let's go ahead and plot the points. This is very similar to how we're going to test you. 3, 4, 5, 6. So there's my M. There's my N. So here's M and N. Want to connect them like such. Draw MN. Find the slope of MN. It's decreasing. So look, I can just count my rise. Down 1, over 1. My slope is a -1. Find the perpendicular slope. That's our opposite reciprocal, so that would be a +1. Use the midpoint formula to find the slope of MN. So we can either just add our coordinates, take the average of the x's, average of your y's, or I can literally see, because this is 4 over 4, I can physically see this midpoint right here. Okay, so I'm hoping we see that this was 5, 4. So you can calculate it or you can see it on the graph if it's an exact point. Now they want us to write the equation in point slope form. This is what we did. Use our midpoint, use our slope. Our equation hopefully should be y minus 4 is equal to 1 parentheses x minus 5. And we're done. Okay. Now on the last set of questions, you have to, there's a couple things that's missing. On 18, they forget to tell us that x is an in-center. So, but because I see this segment right here in that box, that's distance. And the distance from the center, the intersection, to side is congruent. If I was to draw another one, so like if I drew one like that, that's not exactly perpendicular, but it would be also 19.2. These are angle bisectors, so if that's 12, that is 12 as well. And then I can find my first missing angle, which is XR, where am I at? XRQ. I just did because that was the perpendicular bisector, angle bisector, so that was 12. But when I get to PRQ, so PRQ, well, that is 24. And then they wanted me to find PQR, and that is here. So I'm going to use my red triangle to get that. So I know that angle P over here is 52. We know this angle over here is 24. I'm going to add those together, subtract it from 180. So 24 and 52 will give me 76, so we have 104 for our missing angle. Okay? Now, on 19, because I see the TIG marks and I have the box, this is the perpendicular bisector right here, SR. So you should know that. So we should be 2 9 plus 2n plus 9 equals 7n. This was your warm-up. It's a fraction answer, so let me know if you did the warm-up right. And now it's telling me it's a circumcenter. That's our table. The orange table says the circumcenter is formed by a perpendicular bisector. Okay, so this right here needs to be a box and TIG marks. And they want us to find YC. Here is YC. And a perpendicular bisector from the circumcenter to the vertices, they're all equal distance. So because I already know that segment is 63.9. Then YC is also 63.9. And then they want me to find AB. Well, if it's a perpendicular bisector, it bisects the segment. So if I know AD is 62.8, I know you can get AB. All right, so take care of that. Start on your review. Have a good weekend. Thank you for having everything done.